Hey guys, welcome everybody. How are you all doing? So, yeah, plus one, we have already completed our first chapter, and today we are starting chapter number two, relations and functions. So, basically, if you have learned chapter number one nicely, then this chapter is going to be super easy for you because relations and functions are all about connecting two different sets in some different ways. All right. So, if you are new on the channel, quickly subscribe. And if you're already our part of our family, then quickly mark your attendance by hitting on the like button. Okay guys, so basically this chapter we are going to learn about a lot of interesting things. We will learn about ordered pairs, Cartesian product of two sets, their pictorial representations, relations, domain and range of relation. We will learn about functions, again their domain, range, codomain, some different types of functions, and basically some operations on functions as well. Okay, so basically this is going to be like an introduction of relations and functions. Why am I calling it as introduction? Because in plus 2 also your first chapter is going to be relations and functions, and you are going to learn about it in detail even in plus 2. So plus 1 is all about their introduction and understanding of the concepts. Okay, so today's class we are just going to start from the very basics of what are sets, how do we form ordered pairs, what is Cartesian product, and what are relations. Okay, so yeah, quickly give me a high five and let's begin today's class. All right, now what are ordered pairs, how do we use them, and how they are used in forming relations and Cartesian products. So ordered pair, to understand ordered pair, let's take a very simple example. Suppose there is a set, suppose there is a set A which includes some different cars, like example Innova car, let's say Creta, and name any car that you have quickly. Let's say Swift. Okay, these are the three cars we have in set A. Now set B contains color of the car. Okay, it can be red, it can be blue, it can be white, it can be gray, anything. Okay, now if I want to basically represent that, suppose the customer asks that Innova car is available in which colors. So I can represent it in the form of an ordered pair. So I can form ordered pairs as follows. Innova of white color. So I will denote the car name and the color separated by a comma. Similarly, I can denote that Creta is available in red color. Or I can also represent Creta is available in gray color. Right? Similarly, Swift is available in green color. So like this, what I did, inside a bracket, I wrote the car name as well as the color name separated by a comma, and I basically formed the ordered pairs. Okay. So an ordered pair is basically formed by two elements that are separated by a comma and written inside parenthesis brackets. Understood everybody? Now, a good point to be noted here is two ordered pairs can be equal also if and only if the corresponding first element are equal and the corresponding second elements are equal. That means what? If I say that the ordered pair AB is equal to ordered pair 3, 4. This implies that A is equal to 3 and B is equal to 4. Understood? So ordered pairs are equal if the first element is same as first element and the second element is same as second element. Alright. Let's quickly solve a question. This type of question will definitely come for 1 marks in your paper. So this is the first ordered pair. This is the first ordered pair. So this implies x by 3 plus 1 is equal to 5 by 3. So x by 3 will be 5 by 3 minus 1. Now 5 by 3 minus 1 is basically x by 3 is 5 minus 3 by 3. So x by 3 is equal to 2 by 3. This implies that x is equal to 2. Answer number 1. Similarly, y minus 2 by 3 is 1 by 3. The second ordered pair and the second element of the first ordered pair with corresponding second element. So y is 1 by 3 plus 2 by 3. 1 by 3 plus 2 by 3 is 3 by 3. That means y is equal to 1. Like this, I have simply got my x and y values because I know that if the ordered pairs are equal, their corresponding first elements and second elements are same. Alright. Now, let's understand why are we studying about ordered pairs? What is the use of them? So, basically, we are going to learn about now Cartesian product of two sets. Suppose you have two non-empty sets P and Q. The Cartesian product P cross Q is the set of all ordered pairs of elements from P and Q. That is, P cross Q is basically every ordered pair where first element belongs to the first set, second element belongs to the second set. P belongs to first set, capital P, and small q belongs to second set, capital Q. Understood? I know, not understood. Let me explain. So, suppose our set P basically has elements A, B, C. Clear? Set Q is having elements 1, 2, 3. How many ordered pairs are possible? So, the possible ordered pairs are taking one element from here, taking one element from here. Now, basically, P cross Q will contain all sort of ordered pairs possible. So, what all ordered pairs are possible? A with 1, A with 2, A with 3. Similarly, B with 1, B with 2, B with 3. Similarly, C and 1, C and 2, C and 3. Apart from this, is there any other ordered pair even possible? Not possible, right? So, if I take set P and set Q and if I find out the Cartesian product, I will get a new set. This is what? This is a new set which contains all ordered pairs. What kind of ordered pairs? Ordered pairs where the first element belongs to set P, the second element belongs to set Q. Is this clear to everybody? How we find Cartesian product? Okay, let me take another example. Suppose set A is having two colors, red and blue. Set B is having three objects, B, C and S, where B represents bag, C represents coat, S represents shirt. So, A cross B will be what? A cross B will be taking one element from A, one element from B. Similarly, red with C, red with S. Again, blue bag, blue coat, blue shirt, and our ordered pair set is made. This is nothing but the Cartesian product of the two sets A and B. Alright. Okay. Again, an important point to note over here that if either of P or Q is a null set, then P cross Q will also be a null set. Why? Simple. I am telling that my P set contains nothing. There is nothing except a ghost inside it, okay? And the Q set is containing two elements. So, one will form a pair with what? How can you form a pair with nothing? Not possible, right? So, therefore, P cross Q will also be a null set. It will not contain anything, right? Okay, some more important points regarding the Cartesian product of two sets. First point, if A and B are non-empty sets and either A or B is infinite, then A cross B is also infinite. Obviously, if set A is having unlimited numbers, then the ordered pairs will also be unlimited. Now, 1 with A, 1, 2 with A, 3 with A, 4 with A, and so on, go on, go on, go on. So, if your set is infinite, then the cross product will also be infinite. Similarly, if you are finding out cross product of three sets, what will happen? Well, simple. Instead of ordered pairs, you will get ordered triplets. 1, 2, 3. So, inside the bracket, you will have three elements. This is set, first set, second set, third set element. Okay. Lastly, if there are P elements in set A and Q elements in set B, then there will be P into Q elements in A cross B. This is very, very important. It is going to be used also ahead. Okay. So, please remember, if the number of elements in set A is P, number of elements in set B is Q, then A cross B, number of elements will be PQ. Alright. Okay guys, let's do some quick questions and then we will learn about relations. If set B is having three elements A, B, C, set Q is having one element R, form the sets P cross Q and Q cross P and tell are the products equal. What do you guys think? Will we get same set or not? Let's find out. P cross Q will be basically ordered pair. First element here, second element from here, like that. So, A with R, then B with R, then C with R, correct? And what will be Q cross P? Q cross P will be first element from here, second element from here. First Q, then P. So, it will be R with A, R with B and R with C, right? Now, are the two products equal? Do you think that A comma R and R comma A same to same? No, they are not same to same. Therefore, P cross Q is not equal to Q cross P. The ordered pairs are not same, right? Okay, now again a very, very interesting question. If set A is having only two elements, minus 1, plus 1. Find cross product of A with A with A. So, this will be what? A cross A cross A will be equal to ordered triplet, three elements. Now, three elements can be either 1 or minus 1. Okay. So, your first element can be 1 or minus 1. Got it? So, it will be like 1, 1, 1. Or it will be 1 minus 1 minus 1 or 1 minus 1 plus 1 or it will be 1 plus 1 minus 1. Similarly, this can be minus 1, 1, 1 or minus 1 minus 1 minus 1 or minus 1, 1 minus 1 and minus 1 minus 1 plus 1. Apart from this, is there anything else possible? Not possible. So, my number of ordered pairs are going to be 8 in the cross product of A cross A cross A. Alright. Okay. Next question. If set A is 1, 2, 3, set B is 3, 4, set C is 4, 5, 6, find A cross B intersection C. Now, in the first chapter, when we were studying about sets, we learned what is B intersection C. What is B intersection C? So, first of all, B intersection C is what is common between B and C. What is common between B and C? Tell me. 4, 4. Anything else? No. So, what is common? 4 is common. Therefore, B intersection C will be 4. Now, A cross B intersection C is basically 1, 2, 3 cross product with 4. So, it is going to be the set with ordered pairs 1 with 4, 2 with 4, 3 with 4. Simple. This is my A cross B intersection C. Clear to everybody? Understood? Awesome. Next question. The Cartesian product A cross A has 9 elements, among which are minus 1 and 0, one of the elements, 0 and 1, one of the elements. Find the set A and the remaining elements of A cross A. Now, this is a very interesting question. Now, since A cross A has 9 elements, A cross A has 9 elements. This implies that A has 3 elements. That is why 3 3s are 9. Now, what can be the 3 elements of A? Can you tell? See, A cross A is having ordered pairs 0 and 1. So, 0 and 1 are definitely the elements of A. Then there is another ordered pair with minus 1 and 0. So, that means minus 1 is also an element of A. Therefore, it is there in A cross A, right? So, therefore, A must contain 0, 1 and minus 1. Now, simply you have to find out A cross A. A cross A is going to have all the ordered pairs 0 with 1, 0 with minus 1, 1 with minus 1. Like that, okay? So, 0 with 1, 0 with minus 1 and 0 with 0. Similarly, 1 with 0, 1 with 1, 1 with minus 1 with 0, minus 1 with plus 1 and minus 1 with minus. So, these are the possible ordered pairs present inside A cross A. Clear? Understood? Great. Now, here is a quick question for all of you. I am giving this question as homework. Very easy peasy question. Quickly solve and tell me the answer in the comment section. Well, there is nothing to solve actually. There is only logic to be applied. Okay. Coming on to what are relations of a Cartesian product of two sets. So, a relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. What do we understand by that? So, suppose you have two sets A cross B. So, suppose let me take the example that set A has elements A, B, C. Set B has elements 1, 2. So, A cross B will have elements. Element means the ordered pairs A with 1. So, I should not take A, otherwise you guys will get confused with set A and element A. Let me take C, D, E. So, we will basically have C with 1, C with 2, then B with 1, B with 2, then C with 1, C with 2. Right. So, these are the elements of the cross product A cross B. Now, if I define which is a subset of the cross product AB. Now subset means I can define the relation R as only ordered pair having C as the first element. So which ordered pairs have C as the first element? C1 and C2. So like this I basically defined a relation on the two sets, and this relation is telling me that the first element of the ordered pair can be only C. It can't be anything else. So R is basically a subset of A cross B, right? Okay. So what do we understand by relations? It is represented algebraically either by roster method or set builder method, where we can define the relationship between the elements of first set and the second set. Therefore, only a certain number of ordered pairs are selected from the cross product which fulfill the given criteria. Suppose set B is having some alphabets like ABC. Set Q is having some names like Ali, Bhanu, Binoy, Chandra and Divya. I am defining a relationship that X is the first letter of the name Y. So I can select a name Y on the basis of first letter of the word. So A for Ali, B for Bhanu, B for Binoy, C for Chandra. I cannot select Divya because D is not present over here. So only these ordered pairs are part of my relation, and this relation is basically a subset of the cross product P cross Q. Understood, everybody? So that's what relations is. Now, quick point to note over here. The subset is derived by describing a relationship between the first element and the second element of the ordered pair A cross B. The second element here is called image of the first element. Okay. So, relation is always a subset of the cross product of two sets. Now, this subset is going to contain ordered pairs. Here, in the ordered pair, this second element is called as image and the first element is called as pre-image. Oh, where have we reached? Oh my god. Yeah. Pre-image. Alright. Okay. Now, last few topics. What do we understand by domain of a relation and range of a relation? Let's understand that as well. Now, the set containing all the first elements of the ordered pairs belonging to the relation R from the set A to set B is called the domain of the relation R. Now, taking the example of A for Ali, B for Binoy, B for Bhanu, C for Chandra. Taking that example, remember? So, I have a cross product in this. No. I have a relation, and in that relation, I have ordered pairs A for Ali, right? B for Bhanu, B for Binoy, and C for Chandra. Right? Now, in this relation that I have defined, what are the first elements? This is the first element, first element, first element, first element. So, if I ask what is the domain of R? Domain of R is all the first element A, B, C. No need to write B two times. Only single time you can write it. What is the range of R? Now, range is all the second elements. Ali, Bhanu, Binoy, Chandra. Right? Ali, Bhanu, Binoy, Chandra. So, this is my range of the relation. Understood? So, domain is basically all the first element of the sets. Range is basically all the second elements of the sets. And if I take the entire set B, that is the codomain of the relation. So suppose there is a set A having some elements, there is a set B having some elements. So all the elements present over here are called as domain. All the elements present over here are called as codomain. But only the elements which form pair. Okay, so if I let me denote it with a different color. Now talking about these three elements, only the elements which are forming pair, they will belong to the range. Okay, so the complete set belongs to the codomain, and in that complete set, only the elements which are basically part of the ordered pair, they are belong to the range. Okay, let's practice some questions. Number 1. Set A 1, 2, 3, 4, 5, 6. Define a relation R from set A to set A such that having ordered pair xy where y is x plus 1. Depict this relation using arrow diagrams. First of all, let me take it bigger. So I have set A 1, 2, 3, 4, 5, 6. I have set A again 1, 2, 3, 4, 5, 6. Now the relationship is second element should be first element plus 1. Second element is first element plus 1. Okay. So 1 plus 1, 2. 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6. Now this is left out, this is left out. It will not be a part of the ordered pairs. Okay. Now in the same question they are asking what is the domain, what is the codomain, what is the range of the relation. So we know that in the domain of the relation we have all the elements, that all the first elements of ordered pair. So we have 1, 2, 3, 4, 5. Remember 6 was not there. Okay. Similarly, in the range, we have 2, 3, 4, 5, 6. We don't have 1. 1 was not a part of the relationship. But talking about the codomain, we have all the elements of the second set. So 1, 2, 3, 4, 5, 6. Everything. Whether it is forming pair or not. Everything will be included. Okay. Next question. Set A is 1, 2, 3, 4, 5. Set B is 4, 6, 9. Define a relation from A to B where X and Y are defined as difference between X and Y is an odd number. So we have to check that difference between which two numbers is odd. So let's check 1 with 4, 1 with 6, 1 with 9. Okay. 1 and 4 odd number. 1 with 6 odd number. 1 with 9 even number. Again 2 and 4 even. 2 and 6 even. 2 and 9 odd. Right? Next 3, 4 odd. 3 with 6 even. 3 with 9 even. Again 5 with 4 odd. 5 with 6 odd. 5 with 9 even. Right? So here also we have odd, odd, even. So which ordered pair satisfy the relationship? So we have here the following ordered pairs. So the relation R is going to have the ordered pairs where the difference between the two numbers is odd. So difference between 1 and 4, 1 with 6 and 2 with 9, odd, right? 3 with 4, 5 with 4 and 5 with 6. So these are the ordered pairs where the difference is odd. Alright. Now, very important point to note over here. If you have a number of elements P in set A and number of elements Q in set B, then A cross B is going to have P into Q elements and the total number of relations will be 2 to the power PQ. Remember. So if set A is having P elements, set B is having Q elements, then A cross B will have PQ elements and the relations, number of relation formed will be 2 to the power PQ. Okay. Now here is a quick question for you. Homework. Solve and let me know the answer in the comment section. Okay. Next question. If the set A has 3 elements and set B has 3, 4, 5, that means again 3 elements, right? Then find the number of elements in A cross B. Very simple. Cartesian product is going to have 3 elements from set A and 3 elements from set B. Set A, set B. That is total 9 elements. Right? Similarly, if A cross B Cartesian product is having the ordered pair A with X, A with Y, B with X, B with Y, find A and B. Very simple. All the first elements will belong to set A. So set A is going to have all the first elements, small a, small b. Set B is going to have all the second elements. What are the second elements? X, Y, X, Y. That means X and Y. That's it. Simple, right? Next, determine the domain and range of the relation given over here. The relation is defined as x comma x plus 5. So take one element from here and the other element will be x plus 5. So my relation is going to have ordered pair 0, 0 plus 5, 5. 1 plus 5, 6. 2 plus 5, 7. 3 plus 5, 8. 4 plus 5, 9. 5 plus 5, 10. So these are the ordered pairs which are going to be inside my relation. Now they are asking what is the domain of this relation. Domain is basically all the first elements. So 0, 1, 2, 3, 4, 5. And what is range? Range is basically all the second elements. 5, 6, 7, 8, 9, 10. That is the range of the relation. Okay. Next question. Set A is having X, Y, Z. 3 elements. Set B is having 1, 2, 2 elements. How many number of relationships can be formed from set A to set B? Well, A cross B is going to have 3 into 2, 6 elements, right? So, number of relations formed will be 2 to the power 6, okay? So, how many relations will be formed? 2 to the power 6. Alright guys, so that's all for today. Let's summarize what did we learn. So we learned about ordered pairs, Cartesian products, relations, their domain, codomain and range. Let's define them once again. What is Cartesian product? Set of all the ordered pair where first element belongs to first set, second element belongs to the second set. Domain is basically the set of all the first elements of the ordered pair. Codomain is basically set of all the second elements of the ordered pair and range is the subset of codomain. Okay. And what is a relation? It is nothing but a subset of the Cartesian product. Alright. So that's all for the day guys. Hope you have understood everything about relations. In the next chapter we'll learn about, in the next lecture we'll learn about functions. Okay. So if you want notes of this lecture, quickly join our Telegram channel. Subscribe to Vedantu Malayalam channel for +1 and +2 regular lecture of physics, maths, chemistry and biology. Thank you for watching. Do leave your comment and feedback. We would love to improvise and help you out. Thank you guys. See you in the next class. Bye bye.